A bit of a lost mainland has been found hiding underneath Canada, and the proof was covering up in rocks that started in Earth's inside, where precious stones structure. The mystery was disguised in a kind of jewel-bearing volcanic stone, known as kimberlite. Kimberlite starts profound underground in magma in Earth's mantle, and gets catching awry jewels as it tears toward the surface during volcanic emissions. The kimberlite, from Baffin Island in northern Canada, was gathered by a jewel mining and assembling organization. Researchers found that the mineral science of the Baffin Island kimberlite coordinated that from an old and tragically deceased mainland that shaped about 3 billion years prior and separated 150 million years back. A segment of that lost landmass, despite everything, grapples some portion of North America, and dependent on the area of the kimberlite tests. The size of that old piece is about 10% greater than recently suspected, scientists detailed in another examination. Finding these lost pieces resembles finding a missing bit of a riddle, led study creator Mio Kopylova, a geologist with the University of British Columbia in Canada, said in an announcement. Earth's territory masses, or mainlands, didn't generally look the manner in which they do now. The principal land masses rose when Earth was only a fretful child planet. These old and huge rough pieces, called cratons, at that point broke to shape littler land masses. One section of the North Atlantic craton is currently part of Scotland, Kopylova disclosed to Live Science in an email. Another section is a piece of Greenland, and one more is a piece of Labrador in eastern Canada. Presently we have discovered one greater section on Baffin Island, she said. For countless years, plate tectonics pushed land masses together to shape Goliath supercontinents, just to pull them separated and push them together once more. The remainder of the supercontinents, Pangaea, started to isolate around 200 million years back, and by around 60 million years prior, the mainlands had part into the 7 that we know today: Africa, Antarctica, Asia, Australia, Europe, North America and South America. Though the planet's first continents fragmented and were lost to time, remnants of the long-lost land masses survive to this day, as stable cores in our modern continents. The kimberlite samples from Baffin Island, which came from a depth of nearly 250 miles 400 kilometers, bore chemical similarities to mantle rock samples from underneath part of the North Atlantic craton in Greenland, according to the study. Under most remnants of ancient continents, the upper mantle contains about 65% olivine, the main mineral of the upper mantle, and about 25% of another mineral called orthopyroxene, Kopylova said. By comparison, the mantle makeup under the North Atlantic craton is about 85% olivine and around 10% orthopyroxene. And the mineral ratio in the Baffin Island kimberlite was a close match to the North Atlantic craton, Kopylova said. Now, scientists know with certainty that part of Baffin Island was at some point joined with the North Atlantic craton, rather than with other ancient continents, according to Kopylova. This is the deepest location where scientists have found a piece of the North Atlantic craton, greatly expanding their view of the first continent from Earth's distant past, the researchers reported. Previous reconstructions of the size and location of Earth's plates have been based on relatively shallow rock samples in the crust, formed at depths of 1 to 10 kilometers (0.6 to 6 miles). Kopylova said in the email. With these new findings, our knowledge is literally and symbolically deeper, she added.